Okay, so we are talking about Turing machine. So, just to recap, it is a 7 tuple. So, it is a 7 tuple Q. This is the finite number of states, input alphabet, tape symbol, and we have delta transition rule Q0, and we have a blank symbol and set of final states. So, here we have a concept of final state. This blank symbol is belongs to this, and input symbol is subset of the tape symbol. Okay. And delta is a rule from Q cross. We take a input we take any symbol, it could be a tape symbol, I mean in general, it could be blank also. We may have rule for blank input. This is going to Q, and it will change the symbol. This machine has a capacity to write. So, it is reading a symbol, it will write a symbol, and then it will decide to go the tape head left or right. So, here we have a tape head. So, this is a xi, and suppose we are at Q, this is pointing here. So, if the delta of Q comma xi, if it is y comma if it is p, then the symbol will be say y, and then if it is right, then this will next will be. So, it is this will replace to y, and next this will be pointing, and our next state is p, like this. So, it will go like this. Okay. And using this we have instantaneous description. So, suppose this is say x1, x2, xi minus 1, and then xi plus 1, xn, then after xn we have b, and so it will be what? This will be like this. Let me just erase this. So, this is going to where? This is going to. So, our tape is position is like this. So, we have x1, x2, and this is xi minus 1, and this xi is changed to y. Xn, and this is b, blank symbol, all the this is unlimited cell, each cell can contain a symbol. And now our state is moved to p, and then this is the tape is pointing to the right. So, right means it was pointing here. So, now it will point to here, and this we have defined by in the last class we have discussed the ID, the instantaneous description. So, ID of this is we are writing this x1, x2, and we are putting the state symbol in such a way that after the state symbol the input symbol, I mean this tape symbol will be pointing like. So, here so it is pointing to xi. So, we put the state here. So, xi will be here. This is the indication where is our tape is pointing. So, after the state symbol, the next tape symbol will be the pointing to the tape. So, this is xi plus 1 like this, xn like this. So, this is going to this symbol, this ID. So, this ID is x1, x2 dot xi minus 1 y. Now, it is pointing to here. So, we will put the p over here, then x I plus 1 dot x. Okay. Now, it may halt, like I mean when it will halt, Suppose we don't have any move for this. Suppose this is empty. We don't have no move for this. Then it will halt. The system will halt, and it will halt in other situation, that is the accepted state. So, if during the transition, if we can encounter with some final state or acceptance state, then that is called, that will be the language accepted, that is the string accepted by the this Turing machine. That means, now if it is going to the next symbol like this, if we have a rule like this delta of, say, now we are reading, now we are at state P and we are reading x I minus x I plus 1, and if it is going to some state, say P 1, and if it is Z, and if still it is R, then it will go to next position x 1 x 2. So, this is pointing now. So, it will replace this by Z, and it will go to the right. So, this will be Z, and then it will go to the right. So, P 1 x I plus 2, this is like this. Now, this from here we go to this, then this. So, from here to here we have a more than one time move relation, we can go to there. So, this is the way we can define the move relation. Now, based on this move relation, we can define the language accepted by this Turing machine. So, given a Turing machine, we have this Q0 is the starting state, B F. F is the set of all final state. So, we say a W is the string of alphabets, only the input alphabets. So, W is A1, A2, say AN. This is the alphabet string. Now, we say that this will be accepted by this Turing machine if we start with this in the tape AN, sorry, tape is not bounded, and we are at Q0, and this is pointing here. This is the first, I mean the initial snapshot of the machine. So, that means, what is the ID? ID is Q0, the way we defined ID, and then we have whole W. So, A1, A2 up to AN. This is the initial ID. This we denoted by ID 0. Now, if this initial ID will move to the some situation like this, some alpha 1, then QF alpha 2. Here we do not care about alpha 1, alpha 2. Alpha 1, alpha 2 are just a string of tape symbol, mixture of input symbol, blanks, all these things. Only thing we do care about the states. So, where QF is a final state. If QF is a final state, then this string will be called, will be accepted by this. I mean, this is the acceptance string. This string is accepted by the Turing machine, and our machine will halt there once we reach to a final state. So, there are two ways we can machine will halt. One is there is no move, there is no transition for a given state and the given input, and another way if we reach to a final state. So, there may be, so like if it is going to situation like this, we have some we are at say QF, we reach, and our tape is like this. No, there is no end over here. So, it is pointing here, and this is say alpha 1 and this is alpha 2 up to this, and we have after that we have blank symbol, and this is pointing here. Okay, and alpha 1, alpha 2 are coming from then we say this W is accepted by the Turing machine M, and collection of such W is called language of the Turing machine. So, we will define the language of the Turing machine, but that is the idea. So, we just in the middle of the executions, once we reach to a final state, then we halt, machine will halt, and that string is the acceptance string. So, we define the language of M like this. So, this is the set of all W. We start with this. This is the initial ID of the machine, and if it reach to a, I mean recursively with the many moves of this delta. If it is reached to a situation alpha 1 p, or we refer as if alpha 2, where alpha 1 where QF is the final state, and alpha 1 alpha 2 are the any alpha 1 alpha 2 are any string of tape symbols. Then we say this is the accepted by the, this is the language of the Turing machine. Okay, now we will take an example, then it will be more clear. Let us take an example. Okay, so yeah. So, let me define some Turing machine M, which is Q sigma delta and then Q 0 D and F. Okay. Now, Q we have say, so this is Q 1 say, and Q is say Q 1, Q 2, Q 1 is the starting state here, Q 3, Q 4, Q 5. There are 5 states and Q 6, sorry. There are 6 states, and Q 1 is the final starting state, and Q 6 is the final state. So, F is Q 6, and input alphabet is 0 1, and tape symbol is 0 1 along with the along with the blank and 2 other symbols x and y we take. Okay. So, this is the way we define this. Now, we need to have the transition functions delta. So, we write the delta in a table. So, let me erase this. So, we write the delta. So, we have the state Q 1, Q 2, Q 3, Q 4, Q 5, Q 6. Okay. Now, so this is the starting state and this is the final state. We put the star over here. Now, what is the input symbol? 0 1, this is the input symbol, and what is the other tape symbol? We have taken x y, and beta is the blank symbol we are using. Okay, so, delta of, we are at say Q 1 and we see a 0 in the tape. So, this is we are telling, this is we are going to Q 2 and is 0 is replaced by x, and we move to the right. So, in some book this is written as in this form x r Q 2. I mean the other way around, I mean this is the symbol we are going to write, we are going to replace the tape symbol, and this is the position of the tape left or right, and this is the new state. So, this is the another way to write that. So, let us write that x r q 2, and we have no move for this, no move for this, no move for this, and for this we have a move like this, delta of, if we are at q 1 and if we see a blank, then it will going to say q 6, and then we go to the, we replace x by blank, sorry, we replace, this is blank again and this is r. So, using this notation, this is nothing but b r q 6 like this. So, if let us fill up this. So, with q 2 we have 0 r q 2, and then with need some more space over here. So, this is 0 1 x y b. Okay. So, this is b r q 6. Okay. Now, with q 2 this will okay, and this is with 1 we are going to replace 0 by right 0 by y, and we are moving left and we are reaching to q 3. And with y this has no move, with y you have a move y r, and then we have a q 2, and we have no move for this. Okay. So, this is from q 3, let me complete this, 0 L q 4, no move for this, and with x we have x r q 5, and with y y L q 3. Okay. This is given, I mean this delta transition is given, and we will see for this Turing machine what are the string it is going to accept. And for q 4 we have 0 L q 4, and this is no move x r q 1 like this, and from q 5 no move, no move, no move. So, we have y r q 5, and with blank we have blank r q 6, and we have no move for. So, this is the transition rules given by given. So, this is an example of a Turing machine. Now, we want to see what type of, what are the strings it is accepting. So, this we can write in graphical way also. We want to see what are the strings it is accepting. So, we want to check first few will say whether it is accepting the string like 0 1 1. This is our W. So, how to check that? So, we start with q 0, and this is the initial ID 0 1 1, sorry, this is the initial ID. Now, we read 0. Now, we have to check delta of q 0 0. So, delta of q 0 0 is this one, sorry, q 1 is the starting state. So, q 1. So, delta of q 1 0 is this one. This means we are replacing the symbol by x, and we are going right, and our state is new state is q 2. So, this will go to, we are replacing, we are going right and replacing this by x, and this is q 2 1 1. Again this will go where? So, this will again take this, this is the, now we need to check delta of q 2 1. So, delta of q 2 1. So, delta of q 2 1 is this one. So, y will be replaced by, I mean 1 will be replaced by y, but here we are again going to the left. So, that means next input symbol will be x, and this will be replaced y, and this is going to q 3. So, this will be q 3, and x will be the next input symbol, and this 1 is going to replace by y. This is the way. Okay. Now, in the next one, sorry, we have so this one is replaced, we have another one over here. So now this is the situation. Now where it is going now? Now this is the symbol it is pointing. So delta of q3 x. So delta of q3 x. Again it is replacing x by x, and it is going to the right, and it is changing the state to q5. So this is basically x q5 y1. Okay, so let me write here this one. So x q5 y1. Now this is, it is reading this q5, then y, and q5y move is like this, q5y. Yeah, we have a move like this. Y is replaced by y, and it is going to the right. So it will go here, and state is again q5. So it is x, y is replaced by y, then it is going right. So it will see 1 there. So q5 will be written here, and 1. 1 is the next input symbol to be read. Now we should have a rule for delta of q5 1, but there is no rule for delta of q5 1. So our system will hold without reaching to the, there is no way, I mean in the middle we are reaching to a final state. So it is no further movement is there. So it is halting, and this string is not accepted. So this is this 0 1 1 is not belongs to L of m, because it is halting without reaching to a, without giving us a final state. Okay. So let us take one example where it is accepting a string. So let me erase this. So let us take another string, say yeah. So let us take another string 0 0 1 1. So we start with q1 is the starting state, and then this is the, now we read this one. So q1 with 0. So q1 with 0 is this move. So so it will go to the right, and this is this will replace by 0 will replace by x, and q1 will go to q2. So x q2 0 1 1. Okay. Now again q2 with 0, q2 with 0, again it will go to the right, and 0 will be replaced by 0. So x 0, q2 will be replaced by, I mean this will be q2 again 1 1. Now this one is the next symbol. Now q2 1, q2 1 1 is replaced by y, and now it is going to the left, and it is, the state will change to q3. So it is going to the left means next symbol it will read this one. So this will go to x, then q3, 0 will be the next symbol to be read, and 1 is replaced by y, y1. Okay. So now this is the next input. So q3 0. So q3 0 is L 0, symbol is same, but only thing the state is changing to q4, and it is going left. So it is come back like this. So it is q4, and then x 0 y 1 like this. So let us start again here, q4 x 0 y 1. So this is the next input symbol to be read. Now if we do this, it will go. So with q4 with x, q4 with x, where we are going, x r q1. So r means it will go right. So x will remain x, and we are reaching to q1 0 y 1. So this is the next symbol. Now q1 with 0, again it will go to the next one, and 0 will be replaced by x. So this is x x, then q2, and next symbol is y 1. Now, this is the next one y. Now, q to y, again it will go to the y will be replaced by y and it will go to the right. So, this will be, this is going to x x y q to 1. So, this one is now going to, we are going to read this one. So, let me just rub this. Yeah, we can use this. So, now the x. So, now let me check this. So, q to 1. So, q to 1 is again it is going to the left. So, this is going to the, left. So, that q to 1 will be replaced by y, that is okay, but it is going to the left means it is q 3 it is going. So, x x. So, now this will be pointing q 3 y 1, this is the next symbol. So, x x q 3 y 1, this is the next symbol. Now, we are seeing a y, at the point of q 3. So, q 3 y, again it is left it is going, but then this will be remain y, but this is again q 3. So, it is x q 3 x y 1. Now, this is pointing now. Now, q 3 x is again going, now it is going to right. So, and the x is remain x, but the state is changing to q 5. So, x, this x is remain x, q 5 y 1. Now, q 5 y is again going to the right. So, it is y is replaced by y and it is remain at q 5. So, x x y q 5 1. Now, q 5 1, sorry x x q 5 y, no, this will be replaced by, somewhere we missed this, this will be replaced by y. At some state we made some mistake. So, you can verify at home, this will be replaced by y. So, once this is replaced by y, then again we will go to the right and we will see a blank there. Once we see a blank there, with q 5 we will go to q 6 and that will be the acceptance state. Once we reach to the acceptance state, we stop. So, this string is accepted, you can check that. I mean, we might have made some mistake over here. So, you can just follow this these transitions and we can verify this, and it is going to the final state q 6. So, this string is going to the accepted. So, this will be given in the lecture now. Thank you very much.